Greetings everyone. This video is about the lightning-proof distribution line. In most parts of the world, the distribution transformer is effectively lightning-proof when protected by a tank-mounted MOV arrestor. Even if the arrestor fails, the transformer will have been protected in the arrestor's last action. The distribution line and transmission lines are the only parts of the modern electrical power system that still need more lightning protection to make it lightning-proof. This video and paper focuses on the methods currently available to the distribution line designers to make their lines lightning-proof. From March to December, lightning storms are present somewhere in the U.S. nearly every day. At the peak of the summer months, several storms together can result in more than 180 strikes per minute. Lightningmaps.org has a great site where one can witness real-time the lightning storms around the world and get a feel for the stress our power systems experience during these months. IEEE 1410 is a guide for improving lightning performance of distribution lines. The working group responsible for this guide have continually improved the guide as new technology and data has emerged. This is a typical distribution line found in southern parts of the U.S. What we see here are the three energized phases with a neutral below and off the image. There is also no overhead ground wire, which is most generally the way distribution systems are constructed. Due to the height of distribution systems and their widespread presence, they are exposed to many direct strikes by lightning and even more indirect strikes. If a surge strikes near a line, it induces voltage on all phases at once. These surges can and will cause insulators on distribution systems to flash over, but only if the strike is near enough and the insulation level is low enough. 1410 gives us an idea of the number of flashovers a distribution system can have as compared to its insulation level. In this graph, we are shown that for insulation levels above 300 kV CFO, it is unlikely that a flashover will occur. But for a CFO in the 100 kV range, 10 or more flashovers per 100 kilometers per year can occur. However, if we put an overhead ground wire on a distribution system, the outage rate is decreased considerably. In this case, for low ground resistance and a CFO of 350 kV, the probability of a flashover from a direct strike on a shielded distribution system is as low as 10 to 20%. If it was unprotected, it would be 100% flashover. If we wish to do better than that, arresters can be installed on the lines as well as overhead ground wires. Arrestor protection of overhead distribution lines is the most popular means of reducing the effects of lightning. However, the methods used today are not quite what they need to be to achieve a lightning-proof line. From this chart found in IEEE 1410, we can see that if we put arrestors on every 3 spans or on every 4th pole, we will get a very good protection from indirect strikes. If we go past the 4th pole, flashovers begin to occur. Remember, this is for indirect strikes. Also, according to this chart in 1410, installing arrestors on every 4th pole will not provide much protection for direct strikes, even with a 350 kV CFO. To achieve a 100% lightning-proof distribution line from both indirect and direct strikes, arrestors must be installed on every phase of every pole. Anything less than that will result in an outage from a direct strike. There are several ways to protect distribution lines from the effects of lightning. IEEE Guide 1410 offers many suggestions on how to improve line performance with and without arrestors. It is quite possible to achieve a lightning-proof line if arrestors are used. The use of overhead ground wire helps, but cannot quite be 100% effective without the assistance of arrestors. This video has been brought to you by members of the National Electrical Manufacturers Association. They urge you to know what is possible in surge protection. And as always, they urge you to keep on learning.